Well, I forgot to bring my, my batteries for my microphone. So there's a chance that I might lose audio in the middle of class today, which if I notice it, I'll just unplug it and go to the microphone that's on the camera, but I've got to notice it. That'll be the problem. So if you see this little blue light blinking, if you notice that, just let me know. All right, so there was a request to do a graphing problem. We have a test on Monday, right? Which one?
Just pick any of the trig functions.
You pick.
Okay. How about 31?
31, half x minus sine x.
Are we going to pretty much review it or no?
A little bit, yes. I mean, there's nothing new today.
Yeah, okay.
Oh, we're not doing 4.5 today?
The optimization? No, I'm not going to do any more optimization. What I have is a kind of a review. It's my fall 2014 review, and there are certain problems on here that I thought we would go through. So I'll hand this out after I do this problem. So this was a graphing problem, right? So let's start going through the graphing stuff. So first of all, we talk about domain. And this one, they already gave us a restricted domain, 0 to 3. I just have to make sure there's no problems in there. And I'm never going to get division by 0, right? 1/2 x is continuous. Sine is continuous. There's no like breaks or anything in those graphs. So this should be a nice, smooth curve. All right? What about symmetries next?
Yeah.
Symmetry, if I try and plug in, let's see, what's f of negative x going to be if I try that? It's 1/2 x and then minus sine of negative x. And sine is an even or odd function. Remember from pre-cal?
It's odd.
It's odd, right? So sine of negative x is actually negative sine of x. So if you go back and look in pre-cal, sine of negative x, or look on your formulas, is negative sine of x. So that's going to make it a plus. So when I plug a negative x into my function, I get this. Do you all recognize what this is? Is this f? Sorry, I should have put f of x. Is this f of x or no? No, it's actually what? It's negative f of x, isn't it? If I put a negative in front of this and change that negative to a positive, I get this, don't I? And so would you agree that f of x is equal to what? Yeah, that's what I meant to say. F of negative x is equal to negative f of x. That's what we have going on here, right? This one is equal to this one with a negative. So what does it mean when this is true? It's odd. And that means it's symmetric over the origin. So it's a double reflection. When I graph it, that's what should happen. But the thing is, I'm not even going to look on the other side, am I? Because I'm only graphing between 0 and 3. But
would you want us to recognize that like on the test?
recognize that it's symmetric, or recognize that you're not going to need the symmetry?
Like say f of negative x is equal to negative f of x. Like if that was the test question, creating that extent.
I probably wouldn't take off if you left it off, because this is on an interval that doesn't have the other side. So I wouldn't take off for that. I would like for you to at least, write down symmetry and then, give a reason as to why you did it or didn't do it. Like,
No, that's what I was going to ask.
Yeah.
If you were, I remember you said that symmetry is not big to you.
it's really not that big of a deal, because if you get all the other information, then it should come out to be symmetric in your picture. All right, so what's after symmetry? Intercepts? All right, so let's try for x-intercepts here. Let's set 1/2 x minus sine x equal to 0. And there is not an easy way to solve that. In other words, there's not like an algebraic way to solve for x here. I mean, you might try this. Might multiply both sides by 2. But you're never going to get x isolated without x being on the other side. So since you can't isolate x here, is not an easy way for me to determine the solution. Agreed? Now, I can determine it by just looking, though. There is one particular value that is pretty easy to check here. Make sure you're looking between here and here. What value of x? 0? X is 0? 0 equals sine of 0 is 0. So 0 works by inspection, doesn't it? Now, you may not have gotten that one. I'm going to put here, x equals 0 is a solution by inspection, just by looking. I don't believe I'm going to be able to find another one, though. There might be another one, but I don't think I'm going to be able to find it. Pardon me?
So really when max, you're only looking between those.
Yeah, but there may be something in there, again, where I get 0. Might be. I'm not 0, where we get equality here. All right, so I'm going to move on. Y-intercepts, I'm going to guess 0 again, right? I plug 0 into the function. I get 0. So my graph is going to definitely look like this. And remember, I'm only looking out to 3, right? How about asymptotes? Let's talk about horizontal asymptotes first. Don't you have to take the limit as x goes to infinity, negative infinity? Am I going to do that? No, why? Because I'm only looking between 0 and 3, so I don't care what happens as I go to infinity, right? Right? That doesn't matter in my graph. So, doesn't apply. Why? Because we're looking only between 0 and 3. Don't apply? Doesn't. Probably makes more sense. Yeah, we have to have a division by 0 for that to happen, which is not going to happen either, right? So I'm just saying none, right? So we're not getting a whole lot of information from the college algebra part, right? But we should still be able to get a pretty good graph. All right, let's see if we can. So it's derivative time. This derivative should be pretty clean. First derivative is 1/2 minus cosine x, right? And the second derivative, while I'm here, is just sine x, isn't it? So let's go ahead and get, that's a lot easier than some of the problems, right? Okay, so let's now get a number line. Oh, wait, I should solve the equation first, huh? Sorry. Yeah. Let's see, when is f prime equal to 0? When does f prime not exist, right? Undefined. I've been using UND for undefined. So where is it 0? I put 1/2 minus cosine x equals 0. And this is part of why you took pre-cal. I want to know, when is the cosine function's 1/2? At what angle? Pi over 3. And there's other answers, right? There's actually other answers to this, but I'm only looking between 0 and 3. So what's another answer? Look, we were looking right here at this angle, right?
Yeah.
Isn't there another one right down here?
So 5 pi over 3.
5 pi over 3. But remember, pi is here, right? And pi is 3.14. So I'm only looking between 0 and 3. So the only angle in radians, right? 0 and 3, I'm not going to have another one. Was it 0 and 3 or 0 and 3 pi?
0, 3.
It was 0 and 3, right? Okay, on the problem. So only one answer? Okay. Is it ever undefined? This? No. So I only have one critical number here, one critical point. So now I'll go to my number line. Remember, I'm only looking between 0 and 3. I'm picking pi over 3, which is in here somewhere. I've got to plug some points in to my function, or into my derivative, right?
0, pi over 2.
We could do 0, right? We could do 3 also. I always like to pick points in between, though. Because what if it turned out that this was an open interval, you know, and they didn't want you to plug in 0? So just to get used to it, what's a number that I'm willing to plug into cosine that's less than pi over 3? Pi, that would be on this side. Pi over 4, pi over 6, right? I'll do pi over 4. I'm going to test that one, and then pi over 2 would be bigger, wouldn't it? All right, we're going to plug those into the first derivative. So let's try that. What's f prime of pi over 4? Well, that's 1/2 minus cosine of pi over 4, right? Cosine of pi over 4. So this is 1/2 minus root 2 over 2. That's cosine of pi over 4. Common denominator is already here, so 1 minus root 2 over 2 is what that is, right? And 1 take away root 2 is a negative number divided by a positive number. So this is a negative number, right? So this is less than 0. So that tells me that my original function here is going down. When I plug in pi over 2, I'm guessing I'm going to get a positive. Cosine of pi over 2 is 1. No? No, sorry. Cosine of pi over 2 is 0. So you plug in, you get 1/2 minus 0, and that'll be 1/2 will be positive. I'm not going to check it. Is everyone okay with that being positive? Okay, so it looks like I have a local minimum at pi over 3. Yes?
Are you okay with us on the test, like plugging it into the calculator and just getting positive or negative?
That's okay, but you know, if it's wrong, then you know.
But as long as you write the equation down
Mm-hmm.
and show you that.
Yeah, as long as you write down, like at least show me what your critical numbers are, then write down like f of, you know, f prime of pi over 4 isn't negative or something. And if you want, you could even put used calculator just so I know. Although, I mean, something like this you might even be able to do mentally, you know, if you know, because I'm pi over 4. It just depends on you, I guess, right? All right, so we move on. Second derivative, sine x. So when is the second derivative 0? When is the second derivative undefined? Well, when is sine x 0? So where is this happening? It's at 0 and 2 pi. Is 2 pi in our interval? No, 2 pi is a little, I mean, not pi, sorry. Yeah. 0 and pi, right? So pi is a little too big. So the only one that is in there is 0, but that's an endpoint, right? So, but I will include it. Is it ever undefined? No. So I go with another number line. Here's 0, here's 3. And I need to pick a test point to the right of 0. I can do anything, right? And I'm plugging into what? Into the second derivative, right? So what is sine of any number that I plug in that's over here? So it's positive, right? Think about it. You're between 0 and 3, right? Your angle? Whatever that angle is between 0 and 3. If you're between 0 and 3, you're in the first or second quadrant. Sine is the y-coordinate. You're always positive. Yes? So sine of whatever angle it is, I'm going to call it theta. This is theta, somewhere in there. I'm not fixing myself to anything, all right? Because I'm thinking about it in a different way. Instead of plugging the number in, I'm thinking about what the function does, sine. This is always greater than 0 if theta is greater than or equal to 0 or greater than 0, sorry, and less than pi. So what does that tell me?
It's increasing.
Concave up. The second derivative, so concave up. All right. We good? Nothing else. We just need to put the table together. Yes.
We just know because it's positive between those, the sine theta is always going to be greater than 0, but less than.
This will always be true as long as the angle I'm picking is between 0 and pi. So if I pick any angle between here and here, I say what is sine of that angle? You're looking at the y coordinate, and that's a positive number. Now you could have just picked a darn number, you know? You could have just picked like pi over 2 and then plugged it in. Sine of pi over 2 is 1, 1 is greater than 0, right? I was just trying to get you to think about it a little more abstractly, that this is true. All right, so now I'm going to do my little table. You'll need a calculator at this point because we have 0, we have 3. The only other critical number I had was what?
0 and 3.
Pi over 3, right? And it looks like it was down then up. It was concave up, concave up. So it was like this and like this, right? So I know how it's supposed to behave, right? So what I said to do is try and take these points and plug them into what? To get an idea of like where things are. The original function. We already know what happens when we plug in 0. We get 0. So we know we're here. We never figured out what's happening here and here. So I'm gonna now go back to the original function, which was 1/2 x minus cosine x. So f of x was 1/2 x minus cosine x. Was it cosine or sine? It was sine, the original one? And it was minus? And now I'm going to plug in pi over. Is that the right function? Yes? That's okay?
You put 2x, yeah, you put 2x,
Yeah. I keep on blaming it on the medication I'm on right now. Now, I actually want to know where I'm going to plot that, right? Like how high I'm going to go with that. So that's why I said we're going to need a calculator. Make sure you're in radian mode. What is sine of pi over 3? It's like √3 over 2. And then you have to find out what pi over 6 is. So pi divided by 6, take away √3 over 2. I know that because that's a common angle on the unit circle. Let's see if we get the same thing here. So this is 0.5235 or 6. I'm rounding a little bit there. Minus √3 over 2, which is 0.866. Good enough. I'm getting a negative number, negative 0.3424, something like that. Close enough? Yeah? Now, before I actually plot this, I'm going to figure out what happens at 3 because I want to know where that is, you know? So let's do f of 3 also. This will be 1/2 times 3 is 3/2 minus sine of 3. So you see, that's not a common angle. So you've got to get your calculator out. 3 takes sine. Make sure you're in radian mode. So 3/2 is 1.5 minus 1.141. So yes, it is positive, but I want to know what the value is so I know how high to put it, right? So 1.359, is that right? And the other one was negative 0.3424. So I'll say, here's 1, right? Which makes this negative 1. So let's see, I'll do the 3 one first. At 3, I'm at 1.3, so I'm like somewhere up here. And at pi over 3, I'm at negative 0.34, which is, I don't know, roughly here, isn't it? Y'all agree with that picture? So if I draw this, it's got to look like this. So it's got to come like this, local minimum. And then it's got to look like this, like that. Now, I have an x-intercept here somewhere, right? But we already said we can't find it. And that's OK if you don't find it, because I wouldn't expect you to be able to solve that algebraically. It wasn't possible. All right. Good. Now let me hand out this thing. You could just take this, grab one, pass them back. Now don't freak out, because this is not your review for your exam, all right? There's only certain ones on here I want us to look at. All right, the ones that we should look at, number 3. All of them, okay? Thank you. Number 4, number 5, and number 6. Three through 6. All the other ones you either have already been tested on or we have not talked about. So number 7 is an optimization problem, and we just barely got into that last class. So what we'll do is on Wednesday of next week, we'll continue with optimization. I realize that's the day before Thanksgiving. I'm required to be here. And I'm required to tell you that you are supposed to be here. So I'll be shooting a video. Whether or not it's going to be just me or not, I don't know. We'll see. But I will be here doing more optimization on Wednesday of next week. Next Monday? This next Monday? Is that what you're talking? Yeah, the upcoming Monday?
23rd, right?
I think it is the 23rd. That sounds about right. Yep, 23rd.
And so we won't be testing on optimization?
You will not. It would appear maybe as a bonus.
Okay.
All right, so here's what I was thinking I would do. I would have you look through number 3 right now. You pick one for me to do, and then I'm going to pick one for you to do. And you're going to work on it for a little while. And then we'll move on to number 4, and we'll try and do the same thing. We'll see. We'll just do that till we run out of time. All right? So let's see. Y'all take a look at 3.
Maybe do one as a quiz, take a quiz grade in.
Yeah, we might do a quiz. Just, we'll see. Like an effort quiz, like a group quiz type thing. Have y'all seen that commercial where the guy is walking his kid? I don't know if it's a girl or a boy. I think it's a boy. Where he's walking off the field and he's got his son's trophy in his hand, and it says like participant or something like that. And he gets all upset. He's like, it's you can hear what he's thinking, right, in the commercial. Have y'all seen that? And he's like, it says participant. He's like, something like participant. We were we won every game, like, participant. So he tears off the label and he writes champs or something like that. And then he gets in the car and hands it to his son. He's like, here you go, champ, or something. And it just, I don't know, it made me think, you know, participation ribbons, you know, for just showing up. A quiz, 100, you know, just for being here. I'm not a big believer in that, but here I am doing it. All right, which one on 3? Why F? Because it looks the hardest, because it's the last one? All right, so you want F?
Yeah.
Okay.
Does everyone else?
Is that all right, F? Anyone else want to see something else?
I don't know, I would argue C.
C?
C or F?
C or F?
I think F.
Let's vote. C? F? Okay, let's start with F. And if we have enough time, we'll do C.
Since all of them wasn't an option.
So I gave my students in my Cal 2 class their test yesterday. And I gave them a review, but it wasn't a review like this. It was a review of each section, the topic that I wanted them to know, and then in the book, what page and what number problem they should look at that goes with that topic. And I gave them the test, and only 2 people were able to solve a particular problem that was pretty much exactly what I told them to look at. And I was just like totally flabbergasted. Like, how can you walk into an exam when someone's told you what to look at and have no idea what to do? That was the thing. The things that they were doing for the problem had nothing to do with the way they were supposed to do the problem. And it's just kind of like, what? What is going on?
After you do all those videos that explain the homework and all that stuff, they said,
Yeah, I don't get it. But the reason I'm saying that is because when I give you this review here, I'm looking at these problems. I'm not saying, you know, I'm necessarily going to give you like any one of these. You should just know the method and be comfortable with the types of algebra that occur in all of these different problems. Unfortunately, I can't give you a test that has 40 of these problems on it, right? We don't have enough time. So I have the unfortunate task of picking a problem, and hopefully it's not the situation where, you know, you tried 3 of them and I picked the one type you didn't try. Hopefully it's you've tried them all and you're comfortable with all. That's the idea. All right, so getting to this. I'm supposed to find the maximum and minimum on a closed interval. That changes the game, doesn't it? It's the closed interval method. So what I'm going to first do is make sure I have a continuous function on the closed interval. So is this a continuous function? F continuous on the closed interval? Yes or no? What do you think? Yeah?
yes.
Okay, if we rewrite f of x, it's really x squared over e to the x. That's another way of writing that. And that's a continuous function because the top is continuous, the bottom is continuous. The only problem you'd ever have is if the bottom was 0. E to the x can never be 0. So this is perfectly fine function. All right, the other thing you have to check is, can you take the derivative of it in that interval? Yeah, that doesn't appear to have any problems. So what do we do once we know it's continuous and we can take the derivative? F prime exists. Yeah, take the derivative. I find the critical numbers, right? I want to find the, so same thing that we were doing before, figure out where the derivative is 0, where it's undefined. So let's do the derivative. And this is where people are going to vary in how they do it. Some people are going to leave it like this and use what? Product rule. Some people might switch it to this and use quotient rule, right? Both ways should get you to the same result. So what would you prefer, product rule or quotient rule? Product, because that's, you probably would have left it like that. So if I'm going to do the product rule, take the derivative of the first one, which is 2x, right, times the second one, e to the negative x, plus. Now what's the derivative of e to the negative x? Minus e to the negative x, and then times the x squared. So I'm going to do this a little slower. I'm going to say derivative of e to the negative x is itself, right? Times the derivative of what's up top, which is -1, then times the first function, which is x squared. So that's chain rule, right? Derivative of e to something is itself, then times derivative of what was up here, finish off the product rule. Cleaning up. This is 2x e to the negative x minus x squared e to the negative x. That's our derivative. Now I'd like to know where that's 0. I'd like to know where it's undefined. So where's the derivative 0? Well, and where is it undefined? It's never undefined, right? Because just like we said before, even if you were to drop these e's down to the bottom, you can never make them 0, right? So we don't have to look at this. But setting it equal to 0, what have we kind of learned after doing enough homework and problems in class? We want to somehow factor that, right? Try and factor this out. So do they both have something in common? An x and an e to the negative x, right? Can pull all that out. I'd be left with 2 minus x. That's it. 2 minus x. And now I set each of those equal to 0, don't I? Each factor. So I'm going to set x equal to 0. I'm going to set e to the negative x equal to 0. And I'm going to set 2 minus x equal to 0. All three factors. So I get, this answer is trivial. I just box it up. This answer is trivial. I just move things around. That'll never be, right? E to any power can never be 0. Yeah? Yes? So I have two critical numbers. What do you do with these critical numbers?
Plug them into the original function.
That's right. See, this is where the closed interval method's different than what we've been doing. So what I need to do is I need to plug these points into the original function and plug in the endpoints and compare all of them. So what were my endpoints again? 0 and 4. So this critical number is also an endpoint, right? So I only have to do it one time. So here's f of 0. I need f of 2. I need f of 4. And I'll just put a little mark on these. These were my endpoints, right? You always have to have your endpoints in there. It just so happened that in this problem, one of my critical numbers was at an endpoint. Into the original function, right? So it was x squared e to the negative x was the original function. So this is 0 squared times e to the negative 0, which is 0 times e to any e to 0 is what? 1. So this is just 0. What about 2? 2 squared times e to the negative 2, which is 4 times e to the negative 2, which is the same as 4 over e squared, if you so desire to rewrite it that way. So I'll get my calculator out for this. I may not need it, though. Let me see. Let me try the next one. This one is 4 squared times e to the negative 4. This is 16 e to the negative 4. This is 16 over e to the positive 4. So what's the smallest number I have here? The smallest one I have is 0, right? These are these are both positive numbers. So this is going to be definitely where I have a minimum. Which one of these is bigger? So maybe you get your calculator out for it. 4 over e squared. This is a max. So how do I want you to write this on the test? How do I want your, how do I want you to put this at the end and box up an answer for me? You say something like this. You have a minimum at the point, what?
0.
0, 0. So I asked you to list it out as a point, right? And then you have a maximum at, what, 2, and then 4 over e squared. All right?
So the absolute value
The-
of the
I was going to ask you that. These are the absolute maximums and minimums.
okay.
Because we're on a closed interval, you have to have a highest and a lowest point. These are not, these are more than just local minimums and maximums. It's for our function, which was only drawn between 0 and 4, this is the highest and lowest point. Okay? All right, so you wanted me to do C. Would you like to try C? Why don't you try C, and what I'll do is I will go around and I will do C up here by myself, and I won't talk through it, okay? So let's take the next, let's see if you can do it in the next 12 minutes or so. See how long it takes you to do that problem. And you can talk to each other, but try and do as much as you can on your own. It's all worked out up there. I'm going to give
what?
4 is one of those problems where it's kind of like my Cal 2 I was telling you about. It's like I give it, but then on the test, it's like, what are you supposed to do? I don't even know what I'm supposed to do. Well, if you practice, you're prepared for it, know what to do. So verify, find the value or values of C which satisfy the mean value theorem. So you're probably going to want me to do B, right? Does B look the worst to you, or? No? Let's try B. B. All right, so verify the mean value theorem. Let me remind you what the mean value theorem said. The mean value theorem said that if f is continuous on a closed interval, if f is differentiable, that means you can take the derivative on the inside of it, then there exists a number, c, such that the derivative at c is equal to f of b minus f of a over b minus a. Now that's not a formula that is on your formula sheets. So that's just something you're going to need to remember for the test. I think it's fairly simple to remember. This is a difference quotient, f of b minus f of a over b minus a. That's the slope of a secant line. And the left side is the derivative at some value c. So does this ring a bell when I draw the picture of what happens? You have a function, you connect it. The line connecting these two has a slope, right? That's this side. Somewhere on the function, we should have the slope of the tangent line be the same. That's this one, right? That's happening at some point c. That sound familiar? Okay. So when we do this problem, we're really going to be using this formula. We're going to be working the left and right-hand sides down, and we're going to try and show equality at the end. So let's start with part B by writing out what the function is. Okay. We have the function is x plus 1 over x, and we're on the interval 1/2, 2. So first of all, is f continuous here? Well, there is a problem at 0, isn't there? Can't plug 0 in, but 0 is not in our interval, right? So that's okay? Is it differentiable? Well, we got to be able to take the derivative. Can you take derivative of that? Yeah, I hope. Yes. So we should have a nice clean derivative, and shouldn't be any problems. So the mean value theorem should apply. So let me go ahead and just find out what the derivative is. The derivative of this function is 1 minus 1 over x squared. How did I do that? Did I use quotient rule, or what did I do?
You moved the x up to the -1.
Yeah, I rewrote this as x plus x to the -1. And then when I took the derivative of x is 1. Derivative of this is negative x to the -2. Power comes out, subtract 1. And then from here, I drop the x to the -2 down. And so -1 over x squared. All right, so now let's figure out, let's see, for this formula, I need to know what b and a are, right? That's always given to you. Here's a, here's b, right? A before b. So I'm going to start writing this down left and right hand side, okay? So f prime of c equals f of b minus f of a over b minus a, which for me, the derivative at c is this derivative, plug c in, right? So that's just 1 minus 1 over c squared. That must equal, okay, f of b is really f of 2. Take away f of a, which is f of 1/2, over b, which is 2 minus 1/2. Yeah? Now what is f of 2? Well, you've got to go back to the original function, don't you? What happens if I plug 2 in here? 2 plus 1/2, right? 2 plus a half is 2.5. I'm going to write it as 5 over 2. I'm going to keep it as a fraction. 5 over 2. So working the left side down and the right side down together, I get the top left corner of this is 5 halves minus, now let's plug in 1 half. I plug 1 half here, plus 1 over a half is 2. So this is half plus 2 again, isn't it? Which is 5 halves. All over 2 minus a half, 3 halves. Now I got lucky here because 5 halves minus 5 halves is 0, isn't it? 0 over this is still 0. So what I have now is 1 minus 1 over c squared equals 0. And I need to solve that equation for c. Tell me if this is okay. What'd I do? Common denominator? When can a fraction be 0? What's the only time a fraction can be 0? If the top is 0, right? If the top is 0. So this really just turns into c squared minus 1 equals 0. There are other ways to solve this equation. This is just the way I chose to do it.
So you could move the 1 to the other side and then multiply both sides by negative c
Yes,
squared.
yes, you could do that. I would have done it this way if you were going to do that. I would have moved the negative term to the right,
Okay.
and then I would have multiplied both sides by c squared, and then you're going to be exactly where I am on my next step. And then you take the square root, right? And you get what? Plus or minus 1. But it can't be minus 1 because your interval is between 1/2 and 2, right? So your answer is what? C is 1. So what we're saying is that if you were to graph that function and you were to go out to 1, plug it into the function, take the slope of the tangent line, it would be parallel to the 2 endpoints of the curve, to the line connecting those. The mean value theorem guarantees you the existence of at least 1. You could have 2 different values of c that do the same thing. Like if this interval had been bigger, maybe both the 1 and the negative 1 would have worked. Questions? All right, would you like to try one? Why don't you try C? See how long it takes you to do C. Y'all keeping up here? Y'all following this? Or? Anybody have any questions over anything I have up here? If you're looking. Yeah, that's why I would kind of wondering what y'all were going to do with that. If you agree that this is correct. If it factors, you would factor, yes. I don't know if that's going to factor, though. So what are your options? Quadratic formula. We check it's continuous because it's a polynomial. It's differentiable because, yeah, the derivative is nice. If we plug c into this, we get this. Then we do f of b minus f of a over b minus a. This is a little tricky with the signs. Plug 2 in. Here you get 8 minus 4. That's 4. You plug in negative 1. This is the tricky part. Negative 1 cubed is negative 1. Negative 1 squared is positive 1, but then you're subtracting it. So negative 1 minus 1 is negative 2. But you're subtracting that. So minus minus, so plus. Now the bottom 2 minus